In this video, we're going to explore central angles and something called chord-chord angles. So first, let's talk about a central angle and how it relates to the arc that it intercepts. So the first thing I want to do is show what the central angle actually measures. And in this case, my central angle is the angle CAD, A being the center of the circle. And it measures 118.68. And again, I can move some things around, and it will measure the angle for me. What I also want to know, though, is this arc that it cuts off, which, again, if I take this angle and kind of draw it out and trace it, it's going to intersect the points C and D. So we have this minor arc right here. I want to see what it actually measures. And, oh, look at that. Measure of arc CD appears to be the same thing as the measure of angle CAD. Well, I don't know if that's true. Let's move it around and see. It doesn't change at all. Even if I go past 180, still that relationship. That the central angle and the arc that it intercepts are exactly the same in measure. So how do we apply this? So on a problem like this, we want to find the measure, let's do this one here, the measure of BC. Start with a basic one. And so we have the measure of angle BAC, which is our central angle. Told us it's 6x plus 5. And then we have the minor arc BC, which is x squared minus 2. Well, in order to solve this, because the central angle and the minor arc, or the arc that it intercepts, in fact, are exactly the same, I'm just going to set these equal to each other. 6x plus 5 equals x squared minus 2. And then I'm going to solve for x so that I can plug it in for BC. So to do that, I'm going to bring everything over to the right side in this case because x squared is positive. That's where I want it to be. I'm going to move the 6x over and the 5 over. And so we'll have 0 equals x squared minus 6x minus 7. And so I factor that. And my factoring would be x minus 7 and x plus 1. So this factor, when set equal to 0, is 7. And this factor, when set equal to 0, is negative 1. Again, we want to double check, make sure that everything that we plug in is legitimate, it works. So if I plug in negative 1, I'm going to run into some issues in both places, here and here as well. So I think 7 is going to be my value back, so I want to plug in. So I'm going to plug that into arc BC. So 7 squared minus 2 is 47 degrees. And let's do one like number 9. I really like this particular question. So both because it's got two quadratic components to it, and the fact that we're not looking just for a minor arc in this case. So I know I have the central angle, angle CAB. That's this angle right here. And again, if I trace that angle out, it cuts off arc BC. So this central angle and this minor arc, it appears to be, are going to be equal. So 3x squared minus 1 equals x squared minus 9x plus 4. Now, I can bring everything over to one side and I can solve. So by subtracting x squared, we're going to get 2x squared. Then we're going to add 9x. And then subtract 4 from both sides, and this is what we end up getting. So I'm going to factor, I've got a 2x and an x. And it looks like a plus 5 and a negative 1. And so x could be one of two things, positive 1/2 or negative 5. Usually we exclude the negative because when we plug it back in, we get a concern. But in this case, we actually don't, and it works out really nice when we plug in the negative number. The 1/2, let's address that real quick. If I take 1/2 squared, which is 1/4, and multiply by 3, I get 3/4. Taking away 1 gives me a negative 1/4. That's not really what I'm looking for. So 5 would be the one that I'm looking at. And if I want to find arc BDC, that's my major arc. So I can just find the minor arc and then subtract those. Plugging in negative 5, I've got 25 plus 45 is 70. And so that gives me 74 degrees. And so the major arc is 360 minus that, which is... little brain cramp there, 286 degrees for the major arc. So that's the first concept. In the second one, what we're going to take a look at is what happens when the vertex is not at the center of the circle. We don't have a central angle, but it is inside, so it's not inscribed, but it's definitely inside that circle. So we've got two arcs here. I'm looking at this angle G, first of all, angle CGF, so that's this guy right here. Also, on the other side of this angle, I've got a congruent angle EGD, which should be exactly the same, because they're vertical angles. So when I'm looking at arc CF and arc ED, the ones that are across from each other, and how does that compare to the measure of CGF? Well, I can tell just on a quick glance that CGF is definitely between CF and ED, but I'm not sure exactly what that relationship is. I'm going to see if I can get the numbers to be a little bit nicer. I don't know if I'm going to succeed very well here. Let's see. That should work, I think. 53.7. Okay. So if I look at these two, again, CGF is between those arcs, between the measures of them. 54.6 and 53.7. They're about 0.9 away. And if I kind of split the difference between those, I get 0.45 away. So happens that if I add 0.45 to here, I get 54.15. If I subtract 0.45 from here, I get 54.15. So what I've got is these two arcs. If I average them out, I'm going to get the angles that are inside here. So it's not the same as the minor arc. It's the average of the arcs across from each other. And that's a key idea. That's what's called a chord-chord angle. It's made of two chords. So in practice, a question like number 8, where we have these two arcs given to us, and then we've got that central angle, what I can do is I can take the average of those arcs. So let's average those two arcs that are across from each other and set that each will a central angle. So I'm going to take 6x minus 2 plus 8x minus 8, and I can divide that by 2, and that's going to give me 67 minus x. Now, I can do one of two things here. I'm definitely going to combine terms. So to get 14x minus 10, I can divide everything by 2 if I want on that left-hand side to get rid of that. That's a possibility. It would become a concern, though, if any of these numbers were odd. I would not really want to deal with the fractions. The other option is I can really essentially treat this as an over 1, cross-multiply, and go from there. And I'm going to do that approach because I think it's going to work for us every time. And I'm going to have 14x minus 10 equals 134 minus 2x. So I can bring the 2x over, giving me 16x. And I can bring the 10 over, giving me 144. And so then x would equal 9 when I divide by 16. If I want to find the measure of BFE, that's this angle right here, this one over here is the same thing. They're vertical angles. So once I find the one, I've got the other. 67 minus 9 would give me 58 degrees. So then what happens then when we're looking for something like this one? We'll just make our last one here, where we want to find the measure of arc BE. To do this, there's a couple things that we have to consider. We have to find out what x is, first of all. So let's find out what x is. Now, if I'm looking at these two arcs there, they have to average out to 100. So when I take 12x plus 33 plus 15x plus 32 and divide those by 2, they have to equal 100. So 27x plus 65 divided by 2 equals 100. 27x plus 65 equals 200. 27x equals 135 when I subtract 65. So x would equal 5. When I do that, I'm going to plug 5 into here, and I'm going to get 72 degrees. Now, because this is 100, that means that this angle here has to be 80, as does this one. So I want to find this arc. Now, there's a couple ways to do this, but really, I think the easiest way, and I could be totally wrong. Oh, I'm sorry. Yeah, I could be totally wrong in this one. You might disagree with me, but I like to think about the difference between them. If this is the average of the arcs, then the difference from here to here should be exactly the same. One might be bigger and one's smaller, but the number difference is equal. So if I'm at 80 and I'm going to 72, that's 8 away. Well, this one has to be then 8 bigger than 70 or than 80. And so that would have to be 88 degrees. And I think, to me, that's the easiest way to do it. Otherwise, we have to set up a new equation and try and find out what BE equals. So again, central angle, exactly the same as the arc. Chord-chord angle, it's the average of the arcs across from each other.